In this video, we'll learn how to name organic compounds. We use the same structure from our last video as our example structure that we'll name at the end of this tutorial. Before we can even think about naming more complex structures like the one on the previous slide, we need to know the names of basic alkanes. Alkanes are essentially organic molecules that lack functional groups. They contain only carbon-carbon and carbon-hydrogen single bonds, with the general formula shown here. They'll have n number of carbons and 2n plus 2 number of hydrogens. Our simplest alkane with only one carbon is methane. 2 carbons is ethane, 3 carbons propane, and 4 carbons is butane. And shown here in the third column are our condensed formulas, and in the last column are skeletal line drawings. And if you need to review those skeletal line drawings, go ahead and review them before moving on with this video. These simple structures are all linear alkanes, meaning the carbons are in a line, or each carbon is bound to only 2 other carbons. But we can also have branching in alkanes. And branching in an alkane is where we have a carbon that's bound to 3 or 4 other carbons. Different kinds of branching have different names, and to illustrate that, we'll look at 3 different kinds of pentane. The first is the one you're probably most comfortable with, linear pentane, or sometimes you'll see this indicated as N-pentane. If we have one branch, we call this isopentane. And here we have neopentane. This is a pentane bearing 2 carbons that are 1 position from the end. We should also note that these pentanes are defined as constitutional isomers. They have the same formula but different arrangements of atoms and different physical properties. These are the alkanes. We can also have an alkyl group that's attached to a longer chain. The carbons that result from branching are also named. So a carbon with 1 other carbon attached is a primary carbon. A carbon with 2 other carbons attached is a secondary carbon, and so on. So looking at a couple of examples, in isopentane, which we just saw, we'll have 3 primary carbons, 1 secondary carbon, and 1 tertiary carbon. In neopentane, we'll have 4 primary carbons and now 1 quaternary carbon. And then remember, with alcohols, we saw that we could classify them as primary, secondary, or tertiary as well. And that naming comes from the alcohol carbon, or the carbon that's directly bound to the oxygen. If that carbon has 2 carbons attached, then we have a secondary alcohol. Okay, now let's talk about the alkyl group itself. The alkyl group is the smaller organic fragment that's attached to the longer chain, or the alkane. Formally, we define these as partial structures of an alkane if we remove 1 hydrogen. So what that means is that if we have an alkane like methane, CH4, and remove 1 hydrogen, we're left with an alkyl group, or in this case, a methyl group, a CH3. And we use the eel, the YL ending, to indicate that we have a fragment, an alkyl group. Our common linear alkyl fragments are shown here, a methyl, ethyl, propyl, and butyl. And again, these are linear alkyl fragments. They're what we get if we remove a hydrogen from the end, or the terminus of an alkane. If instead we remove a hydrogen from the middle of an alkane, then we create a branched alkyl group. So removing a hydrogen from the end of butane gives us a butyl group. But if we remove a hydrogen from 1 position in, it gives us a sec-butyl, or secondary butyl group. If the alkyl group is branched, and here we have that 3-carbon V-shaped structure, this is an isobutyl group. And then finally, when we have 3 methyl groups bound to the same carbon, we have a tertiary butyl group, or a tert butyl group. Okay, now let's put this together to start naming structures. We name according to the IUPAC system, and our name will have 4 parts. First, it will have a locant, which tells us the position of different functional groups or substituents on the main chain. Then it will have a prefix, and that will identify the functional group or groups present. It has a parent name, and that indicates the length of the main chain, or how many carbons are in the main chain. And then it has a suffix, which tells us about the primary functional group present. The rest of this slide is basically a how-to, or a step-by-step naming guide. We'll start by finding the longest continuous chain, and we'll name it as the parent. If there are 2 chains of equal length, we choose the one that contains more substituents, more functional groups. In this example, our parent chain is indicated in yellow and contains 7 carbons. The parent is heptane. Now when we number the parent chain, we need to be sure to start at the end that is closest to a substituent, or a group off the main chain. So we can number this heptane in 2 different directions, and what we see is that with this yellow numbering, our first substituent is at position 3. But if we number in the opposite direction, with this red numbering, our first substituent is at position 4. So the yellow numbering is correct numbering because it begins at the end nearest the first substituent. Okay. Then we're going to identify, number, and name each of our substituents. We'll start at the left and move to the right. The first group we encounter is a CH3, or a methyl group, and it's at carbon number 3. So we denote this as a 3-methyl. The second group we encounter is at carbon number 4, and is a CH2-CH3 group, or an ethyl group. So this is a 4-ethyl fragment. Okay, lastly, we name the compound as a single word without spaces. If we have more than one substituent, we include them alphabetically. We use hyphens to separate numbers and words, and commas to separate 2 numbers. So for our structure here, ethyl will come before methyl because E comes before M alphabetically. So the name will be 4-ethyl 3-methyl heptane. Again, note that there are no spaces, and we use hyphens to separate the numbers and words. Okay, let's pause for a quick concept check. Go ahead and pause the video and then name the alkane shown below. Okay, we'll start by identifying our parent chain. And remember that when you have chains of equal length to choose between, you choose the chain that has the most substituents or groups on it. So here we have an octane as the parent, but make sure that your octane contains as many groups as possible. If you had a different octane identified, then you might want to pause the video and take another stab at it. Once we have the right octane identified, we need to number our carbons. And again, remember that we begin at the end that is closest to a substituent. Okay, once we've identified our parent octane, we're going to identify our substituents. At carbon 2, we have a methyl group. In fact, at carbon 2, we have 2 methyl groups. And in carbon 6, we have another methyl group. Okay, then at carbon 3, we have an ethyl group. And so we might think that when we go to name this compound, we would call it 3-ethyl. Remember, alphabetically, ethyl comes first. 3-ethyl, 2-methyl, 2-methyl, 6-methyl octane. Okay, but that seems a bit silly, right? And so if we have more than one of the same group, here we have 3 methyl groups, then we bundle them together and name the functional groups combined as a dimethyl or trimethyl. So the proper IUPAC name of this compound is 3-ethyl 2,2,6-trimethyl octane. Okay, one more piece before we wrap up this video, and that is naming functional groups that are not alkyl chains. Okay, we've seen these functional groups already, and now we'll look at how we name them when they're substituents on a larger chain. An alcohol group becomes a hydroxy group, and this one is unique in that we can indicate the alcohol with the -ol, the OL suffix. So this structure to the right here can be named as 2-hydroxypropane, or it can be named as 2-propanol. In the first case, the hydroxy prefix indicates the alcohol in the 2 position, and in the second case, the -ol suffix indicates the alcohol in the 2 position. Most of the functional groups we'll see, though, will indicate by using a prefix, not a suffix. The amine functional group is named as an amino, so 2-aminopropane. And a halogen, like a chlorine or a bromine, is named as a chloro or bromo substituent, giving us 2-chloropropane and 2-bromopropane. Okay, now let's wrap up by tackling the question we posed at the beginning of the lecture. So go ahead and pause your video once again and try to name the compound shown here. Okay, we'll start by identifying the parent chain. This one is a little more straightforward than some. We have this nice chain of 6 carbons, or a hexane. And to number it, we want to start at the end with the most substituents, and that will be the left side here, where carbon 2 has 2 groups on it. And then we just number from left to right. Okay, next we need to identify and name our substituents. And I'll start at the left. We have a methyl group in the 2 position, or a 2-methyl substituent. We have an alcohol in the 2 position, or a 2-hydroxy group. And remember that we could choose to name that group as a 2-hydroxy group, or we can append the parent hexane with the -ol ending and name it as 2-hexanol. And then we have an amine in the 5 position, a 5-amino group. Okay, now let's put these pieces together into a name. Remember that we order our substituents alphabetically, so our amino group is first, then our methyl group. And I'll choose to use the suffix ending here and name this compound as 5-amino 2-methyl 2-hexanol.